All right, matrices. So chapter 11 is about matrices. What are matrices? Yeah, we can do one calculator. Boxes with numbers in them, right? I mean, that's what they are. Why did they make boxes and put numbers in them? I mean, aren't numbers alone enough? Why did they feel they needed to put numbers in big boxes like that? Sure. Yeah. Did they just like make this up? Yeah, remember, all of math is just like made up, right? I don't know if I've said that enough times to be clear. Math is made up. It's all in your head. It's not real. You can't taste, touch, or smell math, right? It's all made up. Why did they make it up? Job security. I was brought into the trust as a baby. We just hoist. No, I'm just kidding. You'll feel that way, but it's not really true. It's for real life things. In fact, if they have Google, anybody have their phone? We never can remember why matrices started. So type into Google, anybody can find that. I thought it was for mixing beer or something. Maybe I'm making that up. It was matrices were first, I think, in the 1800s because they were trying to. Anyway, long story short, whatever you find in Google, let me know if you find it. If they needed it to do something real life. They thought it'll be super helpful to have boxes with lots of numbers in them. That'll help us do what we're trying to do. That's how all of math is made up, to do things that are real. So they made up these boxes with numbers in them. They call it matrices. That's the state word. And then once they make up something like that, they got to make up the rules. How do you add these things? How do you subtract these things? How do you multiply these things? How do you divide these things? So here we go. Here's the rules. How do you think you subtract two matrices, two boxes with numbers? Find something? Anybody find something on Google? Let me know if you do. How do you subtract two boxes with numbers?
Subtract each value that's in the same spot.
Yeah, value by value. Is that how you would make it? Remember, they made it up. And they could do whatever they wanted. They wanted to make up a way that would be useful. Yeah, is that what you would make up? Entry by entry? So like you're saying like 0 minus, if we're subtracting these guys, 0 minus 8 there, so that would be -8, and then 3 minus, wait a minute, I'm getting lost. So I did the first one, so minus, so 0 minus 8, and then 3 minus 1, that'd be 2, and then -2 minus 0 would be -2, and 1 minus, is that what they did? Yeah, exactly. It's exactly what they did. 3 minus 5 is -2. 1 minus -8? That's 9, isn't it? Because you add the 8. Did y'all see what I did there? I just subtracted entry by entry. It's a minus in the middle because they told me to subtract. And like 1 minus -8 actually added 8. It's 1 minus -8. So that actually made the 9 there. Etc. Just go entry by entry. That's exactly what they made up too. They just said go entry by entry. If you need to subtract two matrices, just go entry by entry. And that's how you add them too. If this was add in the middle, it'd be the same thing. You just add them or subtract them entry by entry. That's how they made it up. That seems natural, right? Totally natural and normal. Let me ask you, let's just leave it at that. That's what they did. Make sense? You can do it on your calculator. In a minute, I'm going to go to the calculator when we really need it, when it's really hard. But you can do all these. These will be on the part of the test where you can just use your graphic calculator for exam 4. So you can just type in matrix A, matrix B, subtract them. I'll show all that in a minute when we multiply them, because that's when it'll be super messy to do by hand, and we'll really want to use the calculator in a minute. Good for now? So, see what they want here? They want 5B. They're saying take matrix B, which is the 2, 1, this guy, 2, 1, 0. I don't know why they gave me matrix A on this problem. I'm not even going to use matrix A. But anyway, they want me to take 5 times matrix B. So how do you take a single number and multiply like a whole matrix thing? How would you, remember they made it up. How would you make it up? You got to make up all the rules when you make up a new system. How would you make it up?
Well, when you just get one value, plug it in the matrix. Does it just give you a one value?
Does what just give you one?
Well, let's just say if you just entered it in, how will we enter it in? We'll go 3 by 3 and hit enter.
Oh, right. So you'll
take that out. Should you take that value by 5, or do you have to just?
You have to multiply the whole matrix by 5. Yeah, I'll show them the calculator stuff. So what would you do by hand here? Well, how would you make this up for the by hand?
Distribute it.
Distribute it. That's what they did too. They just said, let that 5 go to all of them. So boom, 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 boom. So it would equal, what is that? 10, 5, 0, negative 10, 30, negative 20. That's what they did too. Really natural. You guys could have made this up, right? The next one's going to be weird though. So that's how they made up multiplying by a constant number. Oh, we still haven't multiplied two matrices. That's what's going to be weird. That's where they seem to do something totally bizarre. But so far so good, right? A number times a matrix, just distribute it to all of them. You got two matrices you're adding or subtracting, just go entry by entry. By the way, that brings another question up. How would you add or subtract two matrices of different sizes? Like what if you had 1, 2, 3, 4 and you're trying to add or subtract I don't know, 5, 6, 7, 8, 9, 10. Like two different sizes. What do you think they made up for that? What would you make up for that? How do you, right? We added or we subtracted two matrices of the same size, and that was natural, just entry by entry. But what do you think about two matrices of different sizes? What would you make up?
I don't know, it seems like matrices have their place values, so maybe we just skip one column, or
Just skip the 7 and 10
maybe, I don't know.
side.
Because they're
That's one idea. Yeah, just these 4 add to these 4, and just leave the 7, 10 or something like that. If that's actually not what they did. What if and one problem with that, one thing I would ask you further about is I'd say, well then what would you do with one like that? That's like totally different shape, like not even resembles the other one. How would you add those two? And they get even more bizarre than that, huh? You know what they did? Does anybody know? They had matrices, maybe your intermediate algebra class or something. Anybody remember what they did for adding matrices or subtracting, adding or subtracting matrices of different sizes? If they're the same size, we just go entry by entry. But what if they're different sizes? What did they do? Nobody knows? Nobody has matrix stuff in intermediate algebra anymore? They said, don't do that. I'm not kidding. They just don't do that. In other words, they said, that's never going to be useful. We'll never need that. Remember, math was made up to do things that are real. They said, we're never going to need to do that. Why would you try to add two matrices that are different sizes? There's no purpose to that. We don't do that. So that's it. They just said don't. So you only add matrices that are, or subtract, matrices that are exactly the same size. You don't do matrices of different sizes. All right. So far, so good, huh? Things are going to get weird now, though. Entry or something. I think it'll be easy for you. So here they want me to do 5a minus 2b. So there's like 5 times matrix A, 0, 3, negative 2, 1, 1, 1, minus 2 times matrix B, 6, 1, 0, negative 4, 5, negative 1. How do you think you would do that? You know, huh? You would just do the work, huh? Like, can I just do one entry? Just 5 times 0 would be 0. Minus 2 times 6 would be minus 12 there. Is that okay? So this one was just 5 times 0 minus 2 times 6. And then this one, this next one, this is the first one. This next one would be 5 times 3 minus 2 times 1. What's that? 15 minus 2, 13. We go there, etc. Just work it out. Yeah, again, you can do the whole thing in your calculator if you want to put that in. I'll show all that in just a minute. So that's normal, I think, easy. So at number 4, now they're giving me A, B, and C. I don't know why they're giving me matrix A. They're not telling me to do anything with it, so I'll just ignore it. So they want me to take matrix B and matrix C and multiply them. So they want me to take B, which is right here, 3, 1, 0, negative 4, 4, negative 5. And they want me to multiply matrix C, which is a different size. 5, 1, 5, 2, negative 3, 1. They want me to times, right? It's notice there's no symbol between the B and the C, so that means multiply. So they want me to multiply those two matrices. I've been telling you up to now, this is where it gets weird. Anybody seen this before? Know how to multiply matrices? It's really strange. They did not do what you or I would have naturally done. They did something totally bizarre.
Well, do you do the 310 to the 55 negative 3?
Yeah, it's coming back, huh? Yeah. Okay, so first off, you got to identify the sizes because you want to know the size of the answer matrix. By the way, look, Math Excel's already setting up the answer setup for me, and it's only a 2 by 2. Isn't that bizarre? Why is the answer to multiplying these two matrices, why does Math Excel already know the answer is going to be just 4 numbers, a 2 by 2? How do all these numbers make only 4 numbers? Well, I'll show you. So here's how it works. I'll show you by hand once, and then after that I'll never do it by hand again, and we'll just use our calculator. But I do want you to see it by hand once, because at the end there's some word problems where you have to know what's going to happen by hand to know what the words mean, and then you just do the rest on your calculator. So you kind of got to know what the calculator's doing, and then let it do it. So let me show you what the calculator's doing, what the by hand method really is. First off, you got to identify the sizes. What's the size of this matrix? Remember, it's important to remember you go down first, then across. It's just the opposite of graphing. Remember how graphing we always go X first, go across, and then Y up and down? I don't know why they made it up. They just made it up, just like why we drive on the right side of the road in North America. In Europe, they go on the left side of the road. We just made it up. So that's all they did here. This is a 2 by 3, and this one is a 3 by 2, because you go down first and then across. All right, so it's down 2 rows, across 3 columns, down 3 rows, across 2 columns. Okay, I see that. So what? So again, let me write it up here. It's a 2 by 3. The size is a 2 by 3, and the size of this is the size of B, and the size for C is a 3 by 2. What does that have to do with the size of the answer matrix? Well, here's the weird deal. These inside numbers must be equal. If they aren't, you can't even do it. That's the first requirement. When you're multiplying two matrices, the two inside size numbers must be equal, or you're not allowed to multiply those matrices. That's weird. That means we can multiply matrices of different sizes. That also means in some cases you cannot multiply two matrices that are the same size. Did you catch that phrase? For example, what if I had a matrix that went 1, 2, 3, 4, 5, 6? What's the size of that matrix? That's a 3 by 2. And I wanted to multiply another matrix that's 7, 8, 9, 10, 11, 12. Two matrices that are 3 by 2. They're both 3 by 2, right? Can I times them? No. Why? Because the inside numbers are not equal. Isn't that bizarre? So this is weird right off the bat. They said to multiply two matrices, the inside size numbers must be equal. Which actually means sometimes you can't multiply the matrices the same sizes, even. And you can multiply some matrices that are different sizes. I say sometimes because if they were both 2 by 2s, that would be a case where it is okay to multiply two matrices that are the same size, right? Because then the inside numbers would be equal and it would be okay. So sometimes it's okay, sometimes it's not. It all depends on those inside numbers.
When it was a 3 by 2 matrix,
Yeah, you could certainly add them. Yeah, right. So adding, subtracting is different rules, huh? Good point. Adding, subtracting, only ones that are exactly the same size, 3 by 2 or whatever they are. Multiplying, different set of rules. Inside numbers must be equal. Okay, and what is the size of the answer matrix? So first off, inside must be equal. Inside numbers must be equal. That's like the green light. Otherwise, you're looking at a red light and you can't go. If the inside numbers are different, red light, you can do it. But if the inside numbers are equal, green light, you can multiply the matrices. What's the size of the answer matrix going to be? It's the two outside numbers. You can see it coming, huh? It's these guys. 2 by 2. Outside numbers. So that's the weird thing. The inside numbers tell you green light or red light. If they match, you can do it. And then the outside numbers tell you the size that the answer will be. So that means that's why Math Excel already set up and knew that the answer to multiplying a 2 by 3 with a 3 by 2, the two inside numbers match. It's a green light, go. The outside numbers, 2 by 2, tell you the size of the answer matrix. The answer is a big 2 by 2. Now, it's big. I'm going to make it big here. It's a big 2 by 2. Okay. So all we've done so far is figured out what the size of the thing is going to be. I think all we're going to get through today is this one problem. By the time I do it by hand and then do it by calculator. All right. So here we go. We're going to actually compute the answer now. You ready? You got to get your left hand. It's like, you know what it's like? It's like that old riddle. The thing about coordinating your hands. Can you pat your head and rub your stomach at the same time and vice versa? That's what multiplying matrices is like. Your left hand has to go across. Your right hand has to go down. That's how you multiply matrices. The left hand is going to go boom, 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 3, 1, 0. And it's going to multiply 5, 5, negative 3. They're going to move at the same time. 3 times 5, 1 times 5, 0 times negative 3. Add all that up. That's the first entry. I'll write it all out in detail in a second. Let me just give you the feel first off. So your left hand goes across. Your right hand goes down. They jump at the same time. Multiply, jump. Multiply, jump. Multiply, jump. Write it down. And then, that's all just one entry. And then the upper right, to do the upper right, you go back and you do this upper row a second time. But now instead of left column, you do the right column. See, your starting position tells you where the answer for that work is going to go. Start with the 3 again, now go to the 1. 3 times 1, everybody jumps. 1 times 2, everybody jumps. 0 times 1, write that down, upper right. Then we go down. And now we're going to get the 2 lower answers. Start with the left again, lower left. Negative 4 times 5. Negative 4 times 5, everybody jumps. 4 times 5, everybody jumps. Negative 5 times negative 3. Write it all down. That's lower left. Finally, lower right. Start with negative 4 and 1. Multiply, jump, multiply, jump, multiply, jump. Write it down. All that. That'll be the answer.
You add them right together.
And you add them all up as you go. Correct. So here we go. So I'm going to go across. Start with the 3.
Now,
Start with the 5.
Rule for multiplication, right?
Just for multiplication. 3 times 5. Plus. Then jump. 1 times 5. Jump. 0 times negative 3. So what's all that come out to be? 50. Well, I'll just do it down here. What is it? Is it 20? Yeah, 20, huh? 20. So the upper left is 20. Good so far? Now, everybody see what I did there? Now I'm going to do the upper right. So I'm going to move this arrow to the right column. I'm going to go down the right column. Start again at the 3. So now I'm doing upper row, right column, upper right. So what I get goes in the upper right. See how you coordinate that? That's the part you're going to need to know on the word problems, because they'll give you these matrices at the end of the section. You'll be like a real operator, a person who really does with a computer matrices. Of course, computers do them all, but the operator has to know which way to set it up to tell the computer to do it. And to do that, they've got to know what the computer's going to do. So they'll tell you which way does this matrix go, which way does the other one go, who goes left, who goes right, which way to make them do this result. So you've got to know what's really happening. Even if the computer's doing it, you've got to know what the computer's doing. So going across left, going down on the right. Here we go. 3 times 1. Everybody jumps. Jumps to 1, jumps down to 2. See how my left hand's going across, my right hand went down. 1 times 2, and 0 times 1. See that? 1 times 2 plus 0 times 1. What's that? 3 and 2, 5? Good so far? Are we having fun? Is this totally bizarre?
Not that bad.
All right. Let's keep going. So now we'll go down to the bottom row, left column. Bottom, left. It's going to go in the bottom left. Negative 4 times 5. Negative 4 times 5. 4 times regular 5. So plus 4 times regular 5. Oops, I'm kind of scribbling that there. Negative 5 times negative 3. What is that? Oh, these cancel, don't they? Positive 15. Negative times negative there. Good there? Right? Negative 20 and positive 20 cancel. Negative times negative. Positive 15. Yeah.
Isn't the green 5 supposed to be a 6?
What?
The green 5 in the answer is supposed to be a 6.
3 plus 2. It's 3. 3 times 1 is 3.
0 times 1, just kidding.
Yeah. All right. Okay, so let's keep going. One more, and we've got this thing. So start now. We're going to go lower right. So here we go. Negative 4 times 1. 4 times 2. And negative 5 times 1. What's all that make? 4 must have, is it negative 1, I think? There we go. We multiplied 2 matrices. Let's do it on the calculator. All right, y'all have your calculator. Basically, put this in B, put this in C, and multiply them. But that might be easier said than done. Let me help you. All right. So you put the steps down so you hit, remember how it works on the calculator. You hit second, so the first thing you do is hit second, matrix, go into the matrix menu. Everybody good with that matrix menu? Oops, turn your calculator on first. All right, so the matrix menu, there's 3 things at the top of the matrix menu, right? So right at this, so I went into second matrix, and there's a names menu. That's for naming them when you want to pull them forward. I always say it's like a magic spell, like Harry Potter or something, where you're pulling forward something. We'll do that in a minute. That's your name. See, I can go down there and I can name whatever. Well, let me just do it. Let me just go down to D and hit enter. I'm going to name matrix D. Now, this isn't really what I want to do. But I just want to, if I hit boom, see how it puts D? Here, let me just clear my screen, go back. So if I go down to F or whatever, boom, see how it puts F on the main screen? It calls it forth. That's for calling it forth. If you want to add 2 matrices or whatever, you call it forth and put a plus sign. Then go back to matrix and call forth the other one. Then boom, it'll add them. I did a mismatch, so it doesn't let those 2 add. Anyway, does that make sense how that works? So that's what the names menu. So go over to the math menu. That's for doing various operations on different matrices. There's special things. We're not going to do any of them. That's where there's all kinds of, you can do what's called a determinant and I don't remember what that stands for. The dimensions, fill it, blah, blah, blah. There's all kinds of different special things if you go higher up in matrix world, things you can do. Only thing we've used is the RREF, right? We did the RREF to solve equations in the last section. And then there's go over to the edit menu. Edit is like with a word processing document, right? You just edit the document. You enter the information. That's what we're going to do. Go over to edit and go down to B. So see what I did? I go over to edit and down to B and hit enter. And it goes, oh, you want to enter matrix B now. Everybody see what I did there? So I hit second matrix. I went over twice to the edit menu, and I went down to B, and I hit enter. So over twice to edit, down to B, enter, and now I'm going to enter matrix B. So the size is 2 by 3, 2 by 3, and then I'll just say input B, and then step 2. Oh, and then when you're done, go second, quit. Remember, you always have to quit, which is right above the mode key, right at the top. Whenever you enter stuff, you have to quit afterwards. You have to quit out of the edit menu. And then go back. It's weird that you have to keep going back and forth. Go back into the matrix menu. Go across twice to edit again. This time go down twice to C. And hit enter. And then put in matrix C. So 2 by 3. Input C. And go second quit again. And then finally, step 3. Now we're going to call them forth. Hit second matrix. And you're on the names menu. Go down to B and hit enter. Hit times on the main screen. And then one more time. Second matrix. Names menu down twice to C. Enter. Looks like the word center. C. Enter. And then hit enter one more time. And you'll Oh, yeah, and you'll multiply B times C. That'll multiply matrix B times C. What was the answer we got? 25, 15, negative 1. 25, 15, right? 25, 15, negative 1, yeah. You able to get that? Is that working out for multiplying, following those steps? So you enter matrix B, enter matrix C, and then call forth B times call forth C. Enter. Is that good?
Down later.
Is that all good? Getting that to work out on the old graphing calculator. So that's how we're going to do it pretty much from now on. We're just going to do it with the graphing calculator. But make sure you kind of remember the general thing it's doing, so the word problems you can direct the matrix setup accurately on now. Is that good? Questions I can answer? Are you all able to get that without too much trouble? All right. Well, we're not going to get much further, so let's